Robert Sungenis, here we are in the lobby of the Scotiabank Center during the Fatima conference, Fatima, the Path to Peace. You're giving a talk related to Fatima on the world situation in terms of wars on a global basis, which have been ongoing since the supposed consecration of Russia, that never mentioned Russia, in 1984. But today I'd like to talk about a different topic, one that you have specialized in, a provocative topic, one that elicits laughter from the modern mind. Geocentrism, that the Earth is in fact the center of the universe. Now, I have to confess, long before you got involved, whenever I heard the proposition suggested by certain Protestant biblical fundamentalists that the Earth is the center of the universe, I would laugh because I share the common prejudice against any discussion of the topic. But then I began to think to myself, wait a minute, I don't really accept the modern world's narrative about itself anyway. Evolution is obviously a preposterous theory, which will go down in history as one of the laughingstocks of scientific theory, along with Rudyard Kipling's Just So stories about how the giraffe got his neck. So then I stumbled across your material, and I began to read it, and I began to wade into the complexities of astrophysics, the theory of relativity, the general and special theory, and admission after admission by top physicists and astrophysicists that even within Einstein's framework, it really doesn't make sense to dispute that Earth is the center of the universe. It depends upon how you position the question. So I think we should give you a hearing on this and address common objections to geocentrism, the theory that the Earth is the center of the universe. And the first objection is, well, how can the Earth, which is so small, have the sun revolving around it instead of the other way around?
Yeah, well, this was Newton's problem, basically. He confined his mathematics to the solar system, and in that system, yeah, we would have to agree. The Earth would have to go around the sun because the sun is much more massive. But 200 years later, this guy named Ernst Mach came along, very famous physicist.
M-A-C-H?
M-A-C-H. He's where we get Mach 1, Mach 2 for sound. Okay. And he had a very profound influence on Einstein, as a matter of fact, Einstein's theories. And Mach said, well, the problem with Newton was you confined it to the solar system. Now, if you expand that system out to the stars, you have a whole different system you have to take into account. And in that system, the Earth can be what Newton called the center of mass for the whole universe, or the center of gravity. And if it's the center of gravity or the center of mass, that means the whole universe could go around it very easily with Newtonian mechanics.
How would that work, if you could possibly break that down in terms that laymen can understand? And I have to tell people who are watching this, especially the loony left who thinks this is all ridiculous, if you look at your material, what you're talking about is, at its highest level, very sophisticated physics, involving things that are beyond the comprehension of the average person. Not nonsense at all. But can you break it down in ways that an average person could understand when you talk about center of gravity?
Sure. If you are playing a tennis game and you have a bad game, and you throw your racket, you ever see the way that racket turns around?
Right.
Yeah, it goes wobbly. The reason it goes wobbly is because it's turning around the center of mass, not the geometric center, the center of mass. That is the center of all the mass that's added up in that tennis racket, all right? So just expand that principle out to the universe, and if the universe is equally balanced on all sides in its sphere, then you have a center of that mass.
Okay.
And anything can occupy that center of mass.
So it's a pivot, the Earth would be a pivot point.
Pivot point, yeah.
Okay, I understand. Here's another common objection. Now, wouldn't the stars, if they're going to be revolving en masse around the Earth, wouldn't they all have to exceed the speed of light as they're revolving?
That would be no more true than if you were flying in the Concorde from Paris to New York and you couldn't talk to the man in front of you because you were going faster than the speed of sound.
Okay. Well, that's an interesting analogy.
Yeah.
So that you're saying that within the framework of the airplane, traveling at the speed of sound,
right,
interactions at less than the speed of sound are possible.
Oh yeah, I mean, if the whole universe is rotating, the stars aren't rotating themselves, it's the whole universe that's rotating within that frame. Now, if you took Einstein's theory, Einstein would have no objections to this, because in Einstein's theory, the speed of an object is limited only in the special theory of relativity. So no scientist out there can say, oh, well, you can't say that. Well, of course we can, because his general theory of relativity allowed anything to go any speed it wanted to.
Now, you've discussed the admissions of physicists in that regard, applying Einstein's theory to the facts to say, well, sure, it depends upon your point of reference. You could have Earth as the center. Can you give us some indications of admissions at the high level, at the highest levels of physics by physicists regarding what you're talking about?
Yeah, one of Einstein's famous books written in 1938 called The Evolution of Physics. Now the title itself is interesting because by the time he got to where he was in 1938, physics had evolved in his mind, you see. And it's interesting with Einstein's story because he invented special relativity in 1905 to answer the experiments that were done 25 years prior that showed the Earth wasn't moving in space. So he had to invent relativity. He had to get everything moving because if he had something fixed, then he couldn't explain that experiment. That relativity theory, the special relativity theory, led him 10 years later to the general theory of relativity because he had to add in gravity.
Well, why was that a problem? Why was gravity a problem?
Well,
for his
because
theory?
Everything in the world has gravity. You see, and if you're claiming certain things about the speed of light and you don't include gravity, you're going to have a lot of mistakes. So he eventually figured that out, had to put in gravity into the general theory. When he did, the general theory of relativity made geocentrism viable. Because
Did he admit that?
He admitted it in his book, Evolution of Physics.
This is what impressed me about your collection of studies and information on this. Einstein's admissions, among others. Go ahead. What were you?
This was on page 212 of his book. Anybody can go look it up. And he has a paragraph in there. He says, basically, there's no difference between the Earth going around the Sun and the Sun going around the Earth, because they're just different coordinate systems.
By his own lights.
By his own lights. And that's what the general theory of relativity led him to. So, I mean, it's ironic. The very theory that he proposed to deny geocentrism led to another theory that made it viable.
By his own admission.
By his own admission.
That's simply remarkable. And it just goes to show how, as I say, you have to be skeptical of the modern world's entire story, which it tells about itself, which has to include evolution. And the general theory of relativity is a way to explain the universe as we know it without positing stationary Earth. I think there's a motive at work here, because what you've told me so far is that the evidence is consistent by Einstein's own lights with a stationary Earth.